you made it through 5.4, and now we're going to take a small breather because this is just going to be somewhat a little bit easier, not as much hard concepts. Okay. So what we're going to deal with is what's called the trapezoid rule. All right. And trapezoid rule, what came about is that, you know, we had the left-hand sums and we had the right-hand sums, and people were like, well, how can I make this even better approximation? And what people found, or they found, was that I can do a trapezoid approximation. Okay, and that is that if I break this all up, break up my function into equal parts, just like I did with the left-hand and right-hand sum. Okay, and delta x, in this case, we're going to call it h instead of writing delta x all the time. Okay, so this was our delta x, we're going to call it h. And if we sit up here and we do trapezoids, remember trapezoids are base 1 plus base 2, divide that by 2 and multiply it times our height. So what I'm going to do is I'm going to show you the development of a formula chart, okay, or formula for this. And so I'm going to finish labeling this one x3, x4, x5, and x6. Okay? And I'm going to, find the area of each of these trapezoids. Here we go. So if I find the area of the first trapezoid, okay, and I'm going to say this is area is equal to, okay, so if I find my first trapezoid is going to be x sub 0 plus x sub 1, all divided by 2, those are my two bases, times my height, which is delta x, but I'm going to call it h, plus, and I do the next trapezoid, x sub 1, x sub 2, all over 2, times h, plus the next one. And I know this is going to get repetitive, but I want us to do this so you can see where the formula comes from. Next one. The next one, x sub 4 plus x sub 5 all over 2 times h. Finally, the last one, x sub 5 plus x sub 6 all over 2 times h. And what you should notice, there's a couple of things that will happen. I can factor out a 1/2 and I can factor out an h for every single one of these. So when I do that, 1/2 times h is h over 2, and I'm left with x sub 0 plus x sub 1 plus x sub 1 plus x sub 2 plus x sub 3 plus x sub 3 plus x sub 4 plus x sub 4 plus x sub 5 plus x sub 5 plus x sub 6. And then what happens here? Well, I've got 2x1s, 2x2s, 2x3s, 2x4s, 2x5s. And I can go ahead and put that all together. H sub 2 times x sub 0 plus 2x sub 1s plus 2x sub 2s plus 2x sub 3s plus 2x sub 4s plus 2x sub 5s plus an x sub 6. And that's the formula. I don't have to figure out anymore, okay, what is, each one individually, okay, by factoring things out, finding a formula. This is the formula for it, okay. And it's like, phew, wow, right? Okay, that's a lot of work, okay, but it was a lot of work for the LRAMs too, and the RRAMs, okay. Now, this formula here, you do not have to memorize. Now, all of your problems today will be able to use the formula that you were given here, okay? But you need to realize that you can always do it like this top part here. And I'm going to tell you that on a lot of the finals, or a lot of the tests, questions will give you problems that won't be so, the uniform, because you can only use this if h, your delta x, is the same for every single one. If your h is different, you can't do this anymore, and you've got to do everything like this top row up here. Okay? So let's take a look at the formula in its more formal version of it. Okay, the formula in the more formal version. If I want to approximate the integral from a to b of my function using trapezoids, here's that formula I just showed you. Okay, where a and b is partitioned into n subintervals of equal length. That is very important. I cannot use this formula if h is different. Okay. The other way to do it, to figure out trapezoids, and I could go through all the math if I wanted to, but just trust me, this is like the church of math here real fast. Okay. This right here is the other form. If you know your left-hand sum and your right-hand sum, and you divide it by 2, as long as the n is the same, the numbers, the number of partitions is the same, the number of rectangles, okay, is the same as the number of trapezoids, that will work fine. Okay, you take the left-hand sum plus the right-hand sum, divide by 2, and that's going to get you your trapezoidal sum. All right, so next is problems. It says use the trapezoid rule with n equals 4 to estimate the integral from 1 to 2 of x squared dx. Compare the estimate with the NINT, okay, with the exact value. Okay, so using your calculator. We're not going to use our calculator, but let's go ahead and use our trapezoid rule. So n is equal to 4. With n equaling 4, okay, so what is my h going to be? Again, my h, okay, which was the same as our delta x. This is going to be the same as our h, right? We take our limits of integration, 2 minus 1, all over how many partitions we want? 4. So that's going to equal 1/4. Okay. So my formula says that is going to be h over 2, so 1/4 over 2 times f of 1 plus 2 times f of 1.25 plus 2 times f of 1.5, adding a quarter each time, plus 2 times f of 1.75 plus f of 2. Okay. You go ahead and we'll get our calculator out and we'll calculate, okay, 1.25 squared. So 1.25 squared. Okay. And I'm going to add in there plus 1.5 squared plus 1.75 squared on all of that times 2. It's 13.75. So what I get here is 1/8. F of 1 is 1 plus 13.75. Is that right? Yep. Plus f of 2, which is 4. So this is all equal to 1/8 of 18.75. So I'm going to get my calculator again and divide that by 8, or plus 5. And then divide by 8. It's 2.34375. 2.343. Okay. And let's go ahead and do that on a calculator. I told you we were going to do it by hand, but it would just be easier to do it by calculator. All right. So here we go. Math 9. Math 9. And it's going to be integral from 1 to 2 of x squared dx. enter, and I get 2.333333. That's pretty darn close. And you have to think about that. That's a trapezoid. That's only 4 trapezoids. That's really close for just 4, right? Really close. Not bad. The other thing I want you to notice is I did not simplify any of these, okay, until the very end, okay? That's what you got to do. You cannot simplify until the very end, okay? Do not cut or truncate or anything, okay? What I mean by simplify, okay? Wait till the very end. All right, next one. Okay, it says here, okay, what's the average temperature for the 12-hour period? Okay, observer measures the outside temperature every hour, okay, from noon to midnight, recording these temperatures as follows. Okay, and what the average temperature? Average temperature. So again, you have to be thinking about what you're being asked to find. Okay. So what it's asking for is an average value of my function. Well, an average value of my function means what I really want to find is 1 over 12 minus 1, 12, I guess 12-hour period, okay, 12 minus 0, not 1. The integral from 0 to 12 of this function that they give me. Well, this integral of this function that they give me can be approximated, okay, using what I have here again. So using trapezoid rule, okay. So what is that going to be? So again, what's my h? Each one of my h's, my heights is always uniform here. It's 1 times over 2. So 1 over 2 is just 1/2 times, and this is where it's going to get 63 plus 2 times 65 plus 2 times 66 plus 2 times 68 plus 2 times 70 plus ... okay, plus 2 times 58 plus 55. Okay, so I'm going to pause the video and I'm going to come up with the answer real quick. You don't need to find it for me, and then we'll, I'll go bang, and there's the answer. All right, so here we go. And here comes the answer. The answer is going to be 781. And again, if you tell me that's the average temperature, you give me the answer, boom, you didn't look at the question again. Again, the average temperature. So this can be approximated now by 1/12 of 781. Okay? Now when I do that, this comes out to be 65.8. Oops. 083. So now that's saying my average temperature for that 12-hour period was 65 degrees. Does that make about sense? It looks like it. Okay, because it dropped way off over here. Okay. So you got to make sure you answer the question that's being asked of you. And that's the big thing that you're going to have to look forward in this stuff, is make sure you're answering the question. Okay? Boom. Here's your homework. It's all straightforward from there. It's just exactly what we just did here. All right? If you have any further questions, okay, make sure you bring them the next time we see each other. All right? Bye.